So this tutorial is on milestone 1. I'll just get you a head start on how to start with milestone 1. Here's the top level for your milestone 1 code structure. So first you have the read-only streets database library. This is the library provided to you to access all of the data on a map. And this is read-only. And in your program, you will see the main executable and the street map library. You don't have to do a lot of things in the main executable for milestone 1. You'll do more in the other milestones. The focus of milestone 1 is mainly in the street map library. And the tester executable is the tester code that's used to test your code and grade you later. The main executable and the tester are both only going to talk to your street map library. The load map and close map functions are already implemented. And you will need to implement the street map library that serves as a wrapper to the actual streets database library. So it does all of the load, close queries, and everything that's listed in your m1.h header file. So to start, read the handout first. There's no line in the handout that's not important. So read the handout from top to the bottom, because most of the questions that your TA will get are mostly already in the handout. You will need at least one global variable to pass the performance tests. You can test this statement by trying to pass the performance tests in other ways, but in most time, you will need at least one global variable. And this global variable, you should be choosing the containers from the STL to store them based on your need. So your maps are stored like this. You will have intersections that are nodes in a graph. Each intersection has an intersection ID that goes from 0 to number of intersections minus 1. You have the street segments that connects two intersections together. Each street segment will have a street segment ID that goes from 0 to number of street segments minus 1 for each CT. And your street segments will constitute a street that also has a street ID that goes from 0 to number of streets minus 1. So basically, it's like a graph that's intersections are the nodes and the street segments are the edges. In your main, you're given these two functions. The load map is called whenever your map is being loaded at the beginning. Your close map is called whenever your map is being closed. So you will be cleaning up after yourself. And this cleanup cleans up everything you set in the load map. Originally, these two functions are empty. So without any modifications to your code, first compile your code and run ECE297 exercise 1. And because there's no modifications, you'll likely get something like this. You'll get a build error in ECE297 exercise 1 saying failed to build unit tests. And the errors are undefined reference to some functions. These functions are defined in m1.h. And read through all of the comments to see what you need to do for milestone 1. For each function, it has a line saying what this function should do and a line saying the speed requirement. In this tutorial, we will use this function as an example. So we will implement this function in this tutorial. And you're free to use any code that's provided in this tutorial only. But most likely you'll still need some modifications on it afterwards. So to get rid of all of the compile errors of undefined reference to functions, create empty implementations of the functions in the m1.h. So for each function, create an empty function. If it needs to return something that's empty. So if it needs a return of a vector, then return an empty vector. Until you don't have any build errors with ECE297 exercise. And you'll get this. You should fail all the tests. And your goal for M1 is to pass all of the tests. We have 4 kinds of functional tests, functionality tests, and 4 performance tests. There is 1 test for load maps just to make sure you're not abusing the timing for load map. And you have 1 test for val grind for memory checks. Now let's implement that example function. In m1.h, it says this function returns a vector of all the street segments connected to an intersection. So it returns a vector of street segment ID. It takes in as a parameter the intersection index of the intersection. And you'll need to return return vector with all of the street segments connected to it, with street segment IDs. So in this case, because we only have the intersection index, we have to access some data that's outside the scope of this function in streets database API.h. So open street database API.h, and you'll need to read through it to obtain all the information that you need. In this case, we're just showing the information that's used to store the street segment information. So for each street segment, it has an OSM ID. The OSM ID is different from the street segment ID. OSM ID is a unique ID that is unique universally across all cities, all types. So this is a huge number. Intersection index from and to. Each street segment connects 2 intersections together from to. And this Boolean signifies if it's one way. Number of curve points in this street segment. This could be useful for some other functions, but not this one. Speed limit, useful for your pathfinding. Street ID that this street segment is belonging to. There are other functions that's useful for this function we're implementing now. So we have the get non-intersection street segment that takes in intersection index. This function returns, all of the descriptions are in the comments. So this function returns the number of street segments connected to the intersection. So it's an int. Get intersection street segment. This one returns the street segment index of this intersection represented by intersection index and the segment number that goes from 0 to number of segments returned here, -1. Then you can use the get street segment info and the street segment index to get the info of the street segment as a struct. Usually the naming conventions for all the functions in street database API is like this. So we have the get, signifies this is a lookup function that's usually O1. The entity intersection is usually the first argument in the argument list. So we're getting something for the intersection. And in this case, it's the num of street segments connected to it. So for example, what we need to do for this intersection here at St. George and Galbraith, we first call the get num intersection street segment 232. And this will return 3 for 3 street segments connected to it. Then for each of the street segments, we call the get intersection street segment 232, which is the intersection ID, and 012 for each of the connected street segments to get the street segment IDs. We can then do whatever we want on the street segment IDs using the get street segment info, for example. Is everything up to here clear? Just be careful that the intersection index, street segment index, street index, like all of the index types are all type defs to int. So they're all treated like ints by the compiler. So if you accidentally mix a street segment index with an intersection index, you will not get a compile error. And this could be very hard to debug. So make sure when you are naming your variables for a street segment index, make sure it says street segment in the name, just to avoid some trivial errors like this. Now let's implement this function together. So find street segments of intersection. Remember, we need to load in this vector with the street segments connected to the intersection. So any ideas on how to start with this? Yep. All the street segment IDs. Yep. Use the find thing. So we're given the intersection index, and we want to find the street segments connected to it. Yeah. 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 You use a for loop, and the number of iterations in the for loop is the get num intersection street segment intersection ID. And then you use this get intersection street segment to get each of the street segment index. Is this clear enough? And then you just directly push back the street segment ID. Now, after the implementation of this, and if you run the tester ECE297 exercise 1, And because we just want to test the intersection test, so I can just do -- run tester, start intersection start. And this will only run the tests that have the string intersection in it. And we'll see that it passes the functionality test because it's implemented correctly, but it fails the performance test. And this means that we need to boost the performance further. In M1.h, you'll see a description of the different speed requirements in this milestone. So for a high speed requirement, which is what is defined for this function, it needs to be very, very fast. And it's likely to require creation of data structures, global data structures to allow you rapidly return from the data structure rather than going into the streets database API and building the vector. For something that's moderate, like load map, this is speed tested, but you can most likely use like something like brute force to implement this. Or you can just call the proper streets database API in a more efficient way to pass, yeah. Yeah. So yeah, in the high case, you'll likely need to pre-process some data. And if it's none, then this means this function is not speed tested. Now, for our function, what is the complexity? We assume all of the get functions are O1. What is the timing complexity for this one? Yeah. O of n. Yeah, we usually use k because it's not really a large n. But what is k in this case?
Whatever time value.
Yeah, it's the average number of street segments connected to some intersection. Can we speed up our function? In M1.cpp in load map, you have this comment here, which is a massive hint. Load your map related data structures here. Because load map is called whenever you start your map. So here is where you do the data processing. So you do all of the pre-processing here. You should build your data structures here, and in that function, you just use it. Let me show you. Okay. Yeah, we make a global variable here to store something for the intersection street segments function. So let's think if we just want to do a direct return of some global variable, of a part of some global variable. What data structure can we use? So the input to this function is an integer, intersection ID that ranges from 0 to number of intersections -1. The output is a collection of street segment IDs, so basically a vector of int. And let's take a look at all the data structures that we can use. So the vector takes in as input an integer as the index for random accessing. The output is templated. The list takes in iterator, output is templated. Map and unordered map take in templated key and output templated values. So which data structures can be accessed with an int intersection ID? Which of those four? Yeah. Vectors and vectors is the most straightforward one, but in theory, you can access all of them using an int. Because for maps, you have the template type, so it can be int. And for list, it's inefficient, but you still can use an int. What can these data structures contain? Anything. They're templated so they can contain anything, including a vector of integers. What is the complexity for accessing the elements in the data structure? For vectors, we can use O1 for random accessing. For list, it's ON because it needs to traverse through the list. For map, it's O log n because it's a binary tree. For unordered map, it's O1. It's a hash table. And we want something that's less complex than ON, which is the original function. So we'll pick the two O1s and compare them. Which one is faster? For the vector one, any access involves a direct memory access. So it just needs the address of the first element and an offset to do a direct load instruction. On worded map, first we'll need to call the hash function to get an index and then do the same direct memory access. And this makes it slower than vector because the hash functions are usually slower, pretty slow. So vectors are like arrays. They are indexed using a number. So if you have a continuous range of data that starts at 0 and ends at size -1, this is the best choice. But if the index is not an input is not an index, like if it's not using an integer for indexing like strings or anything else, you should be using the unordered map because it's still O1. If we are looking up with a very big number that doesn't start at 0 and it's not continuous, for example, if you're looking up with the OSM ID that is enormous and that is unique across cities, and this means that for a single city, you will have a lot of empty spaces if you're using vectors, and this will be a too big and wasteful vector. In this case, use our map. But in our case, because we are indexing using intersection indices, which is starting from 0 and ends with number of intersection -1, which is a continuous range that starts at 0. So we use vectors to store a vector of integers. And what does data structure look like? It's a vector of vectors. So it's a vector that goes from 0 to number of intersections -1. And each of the entries contains a vector of integer. And these integers are the street segment IDs that's connected to each intersection. So if we want to access intersection 1's street segment IDs, we just do intersection street segments square bracket 1. And this returns a vector. Is this clear? Anyone needs more explanations? Okay. So we have this global variable defined, and we need to populate that inside the load map function. Because load map is called before any other functions are called. So in the load map, we first load the streets database binary for the current map. We first resize this global variable into the number of intersections, because that's what we know that we need to store. And this will create empty vectors for each intersection. And then we do a for loop that goes from 0 to number of intersections minus 1. Inside each for loop, we do the same thing as we just did in that function. We loop through all of the street segments for each intersection that's indexed using the intersection index. We get the intersection street segment ID using intersection and I, which is the inner for loop. And we push back whatever we got from this function to the empty vector that's created here in the global variable. Is this clear? Is this code okay? So in this case, we loaded all the data that we need into the global variable. And then the find street segments of intersection function just needs a single line of return. Return the global variables index at intersection ID. So in this case, when you call this function, it's O1. It's a single vector lookup to return the pre-calculated vector. Is that okay? Because we moved the complexity to the load map, this function can be completed in O1 time, and we can pass the performance test. Just keep in mind that there is a performance test for load map too, but it's not of a high speed requirement. You have several seconds to load everything into your data structures. So as long as you are not doing something crazy, you should be able to pass the performance test for that. So when you are dividing the tasks, make sure that, because everyone needs to modify the load map. So when you need to do anything to the load map, make sure you're discussing with your teammates and not doing duplicated actions in the load map. And I'll reserve the rest of the first hour to questions on milestone 1.
Structured everything global variables, right? So it would be like declared outside of the.
Yeah.
The flies through bounding box functions. There's a min max latitude and longitude bounds. For like the rectangle that we have this intersection and free. So I just didn't understand what a minimum and a maximum bound of like of latitude and longitude for a bounding box would be like, what is the minimum? What is the maximum?
The bounding box. It's a bounding box with respect to the line. Do you need to rotate? You don't have to rotate the bounding box. You just need to get the maximum length.
Yeah, so, well, I'm imagining like a rectangle, right?
Yeah.
And then, oh, so it's like the bottom.
So it doesn't have to be the most optimal. You just need to get the maximum length.
Yeah, so if we like said like it's a rectangle, right? So they're like both sides. So the minimum latitude would be like the bottom. Is that what you do?
Yeah, let's say this one. If it's still
Certain prohibited.
So this would be like.
Yeah, I think you were two for one TA. One question about those maps. So like, what do you know? Like, what kind of data? I guess are we doing this?
Yes. Yes. Only modify the load map for passing.
But in the future, like when we're trying to in the future, like we should be really working around.
Your public test cases are only on Toronto, but for the other cities will be tested with private tests.
Sure. So other things for those.
But you only load one map at a time. Load one city at a time.
Oh, got it.
Yeah, I'm just curious about the map functions because I think we need to also use these functions in the later milestone. So for now, I think the vector is best data structure, but we can not sure like if it's still the best like data structure in the later.
The functions that you're implementing, which will be used in the later milestones, whatever you create for those functions will be propagated to the later milestones. And if you need to add more functions that's not related to what you have right now, you might need to expand your roadmap further.
So we also need to do some modification.
You'll need to do more.
Well, but now like we should like copy all the function prototypes and m1.cpp.
Yeah, first is to create empty functions, placeholder files.
Okay, and then like let them return stuff.
Yeah.
But that happens in m1.cpp.
Or you can make your own CPP and .h files. if you want. And I'll be covering the coding style guides in the next tutorial, so make sure you're following the coding style, because the coding style will also be marked by the key. So yeah, so as long as it's readable, you can choose where to put all of the functions.
Like a way to make it readable for our group.
Yeah.
Built-in libraries.
Built-in libraries. You're allowed to use anything in the SQL. And anything for the street map database and the OSM database. And if you want to use external, you can also use servers. It's also you can pass that.
I cannot do that. Maybe for like pure software, you can, but if I say like I know like